I'm going to do a couple of questions here where we're going to use similar triangles to solve for variables. Knowing that the triangles are similar to each other can let us know that we have congruent angle pairs as well as sides that are in proportion to each other. Now, I have two questions here that have a very, very common error that occurs that I wanted to show you and kind of warn you about. In this image, I have two triangles, but they are overlapping with each other, and that causes the problem. We have a small triangle here, which has labels of sides of 12 and x plus 1. We have a larger triangle that overlaps with it, and it has the bottom labeled as 3x minus 2, and it has labels along the side KL. And when we are wanting to compare these similar triangles in order to solve for a variable, you must list your corresponding sides in your ratios for your proportion. The common error when people are doing this is they'll set up the small triangle totally fine, saying 12 over x plus 1. But when they go to set up the ratio for the blue triangle, they often will say 20 over 3x minus 2. Now 20 is not the length of the entire side of the blue triangle. And so this is going to cause them to get this problem wrong. You must add together the 12 and the 22 get a side length of 32 to have in ratio with your 3x minus 2. So this is the proportion needed to solve this question to find the value of x. From this point, you're just going to cross multiply and solve. So I'm going to do my cross products here. I'm going to have 12 times 3x minus 2, and I'm going to have 32 times x plus 1. Going to continue solving by distributing. 36x minus 24, 32x plus 32. Going to get my my x's to the same side. I always move the smaller amount of x's, which here is the 32 x's. Leaves me with 4x minus 24 equals 32. I'm going to add the 24 to both sides to isolate the x term. 4x equals 56. Divide by 4 to get x alone. So x should be 14. Again, very common error when people set up the proportion on the right side as 20 over 3x minus 2. You must make sure that you are using the entire side measurement as you are doing this. Now, the reason that that is a very common error is that there is a rule in Friday's lesson that if you have parallel lines in a triangle, then it splits those sides of the triangle proportionally. And so with that problem, you're using the pieces of the side in the proportion. And so in that case, the 20 would be used. So you have to watch out for that. So I'm going to show you one of those now. So here is the rule I was talking about. Edgenuity calls it the side splitter theorem. In our face-to-face class, we call it the triangle proportionality theorem. I don't know who's right with what name, but side splitter is a very weird name. Anyhow, if you have a triangle and you have a line parallel to one of the sides, it will split those sides proportionally. And so here is a sample using this idea based on the side splitter theorem, which side length would complete the proportion. So they have JM, so let me find JM, here it is, over MK, and they have LN over blank. So what has to go into the blank is KN or NK. And so in this problem, you are actually, in fact, setting up the pieces of the sides of the triangle. Now, how that's different from the one I did at the beginning of this video is at the beginning of the video, we were using the side MN and the side JL. Those are entire sides of the triangle. So if you are needing to solve for an entire side of a triangle, then you need to be using, the full side measurement. So if I want to find JL, I need to use the entire side of the triangle, like either JK or LK on the other side. So let's look at another problem. Here's a problem where we are going to solve for a measurement. I'm going to call it X. We're looking for VT, so I'm going to label that as X. So we are noticing that we have parallel lines here, and we are able to use the side splitter theorem, which states we could say 10 over 7 equals 9 over X. So we would get 10X equals 9 times 7, 63, divide by 10, X would be a 6.3. So pretty easy. That one didn't have any algebra in it, so nice and easy to do. The converse of the side splitter theorem also is true. If the line is dividing the sides proportionally, then it is parallel to the base. So if we are wanting to determine the value of X that would in fact make these lines be parallel, then we are going to create a proportion and solve with it. So I'm going to set up X minus 1 over X plus 3 equal to X over X plus 6. Oh darn. Let me go back to my notability. There we go. So we would do X minus 1 over X plus 3 and X over X plus 6. Cross multiplying here, X minus 1 times X plus 6 equals X times X plus 3. So in our solving, we're going to have to do some distribution. Distributing on the right is pretty easy. X times X is X squared, 3 times X, 3X. But on the left side, we have to do double distribution. So double distribution, taking this X times this parenthesis set, and then minus 1 times X plus 6 there. And there's other ways to do this type of multiplication, but this is the one most commonly taught. I'm going to distribute the X squared plus 6X, distribute that minus 1, minus 1X minus 6. Combine those like terms, X squared plus 5X minus 6 equals X squared plus 3X. What's good about this is that we have an X squared on both sides, so as we're trying to solve this and subtracting X squared to bring our X squareds together, they cancel with each other. So we're left with 5X minus 6 equals 3X. Since on the right side all I have is the 3X, I'm going to subtract the 5X's to get my X's together, leaving me with a negative 6 equals negative 2X. Divide by negative 2, 3 is X. And that is the answer. If you ever get two answers, because sometimes you have to factor to solve, you want to make sure that the answer you're getting works for the expressions. Meaning if I take this 3 and I plug it in, that I get values that are okay to have, meaning positive, because these are sides of a triangle. This would be 9, this would be 6. And you could check it. Remember, we're looking for proportionality. 2 over 6 equals 3 over 9. That is a true statement, so you have checked your answer that way.